Hi, folks. Welcome to 3.7, Part 1. Now, in 3.7, we're actually splitting this whole section into two separate parts. And then within each part, we'll have a few videos, okay? So this part should have two videos, and the next part will have a few videos as well, okay? But I wanted to start off today, like we normally do, with what we know and what's new. And so some of the things we know might be this list of parent functions that we've been looking at for quite some time now, all right? So making sure we know what the shape is, how to sketch maybe a few important points on there so we get the right shape, making sure we know our characteristics of these, like domain and range. And then we've been spending some time talking about graph transformations. And so I want to take a moment to write that formula down here. Y equals A f of B of x minus C plus D. All right, so this was something we talked about way back in 1.5. And it's going to be a theme that we use throughout the course. And so I just want to remind us like what A and B and C and D stand for, all right? So our A, that's that vertical stretch or compression, whereas B is the horizontal stretch or compression. C moves our graph side to side, and D moves our graph up and down. Okay, and we're going to come back to this at some point in this lesson. So I just wanted to prime us for that. If you need to go back to your 1.5 notes to double check, not a big deal. All right. Now, what's new today, we're going to learn a new parent function called the reciprocal function and study that class of function. Okay. All right, so we've got a new function here, my friends. It is called the reciprocal function. And so we're going to take a step back. We're just going to say, let's have this equation, f of x equals 6 over x, and let's just do what we know how to do, which is fill in an xy table, okay? All right, so if I plug negative 12 in for x, I'm going to get 6 over negative 12, or negative 1/2. If I plug negative 6 in for x, I get negative 1. If I plug in negative 3, I get negative 2. If I plug in negative 2, I get 6 divided by negative 2 is negative 3. And if I plug in negative 1, I get negative 6. And last but not least, if I plug in negative 1/2, I'll get a negative 12, right? And so before I do the rest of the points, I'm going to go ahead and plot these 6 points on our grid. All right, so negative 12, negative 1/2, negative 6, negative 1, negative 3, negative 2, negative 2, negative 3, negative 1, negative 6, and negative 1/2, and 12, all right? Now, it turns out that these 6 points actually make one of something we're going to call branches of our graph, all right? So what we have here is the first branch of a reciprocal function. Now let's go ahead and we're going to plug in these other 6 values, okay? Which should be the same as what we got before, but now they're all going to be positive, all right? So 6 divided by 1/2 is 12, 6 divided by 1 is 6, 6 divided by 2 is 3, 6 divided by 3 is 2, 6 divided by 6 is 1, and 6 divided by 12 is 1/2. And so I'm going to go ahead and plot these other 6 points. So 1/2, comma 12, 1, comma 6, 2, 3, 3, 2, 6, 1, and 12/2. All right. And just like before, I'm going to go ahead and connect these with a nice smooth curve. Now I've got the second branch of my graph. All right. Now, in addition to having two branches for this, which is different than some of our other graphs have been, this graph also has some other interesting characteristics. And in particular, it has this sort of line that the function gets close to, but doesn't really ever get to. There's a horizontal one. And in fact, we call this a horizontal asymptote. And the equation for this particular asymptote is y equals 0, because every single point along this line has a y value of 0. Now, if we look very carefully, we might also see that we have this sort of special line, okay? This one, my friends, is what we call a vertical asymptote. And similarly, it kind of divides our function into our different branches. But in this case, our function will definitely get close to it, but it won't ever cross that, okay? So our vertical asymptote in this case has an equation of x equals 0 because every single point on this line here has an x value of 0. All right. So let's kind of get this right here on one page for us. So we plot some points. We find out that in this case of the reciprocal function, we actually have two different pieces. Okay. So let's go now and define what the basic reciprocal function is, or the most simple reciprocal function. Turns out that this equation is f of x equals 1 over x. All right, so when we make that numerator 1, that's the most simple version. And if we were to plot some points, we would find that we still have this situation, as well as this situation. And we would find that the points 1, 1 and -1, -1 are on our graph. And the rest of the points, I'm going to say, don't matter as much for us. We do want to make sure we get a nice smooth curve here like this. That's one branch. And then we have another branch over here. Okay. Now, looking at this picture, do we want to say this is even, odd, or neither? All right, now let's remember our definitions of even, odd, or neither. Even would mean that this could fold over and match something over here. And I don't see that. It doesn't look like a volcano to me. But it does look like this point gets reflected here and then again down here. And when we have that double reflection, that's when we know that our function is odd. Okay. And as a reminder, that means f of x is equal to negative f of negative x. All right. Now, let's look at our domain and range. All right. When we're looking at our domain and range, we might notice that, like, I have all these x values over here, and I have all these x values over here, but there's one x value that I don't get at all, and that is right at x equals 0. Okay, so the way we write our domain is we say from -infinity to 0 in union with 0 to infinity. All right, so we're leaving out that one point. All right, let's talk about the range. Looks like I've got y values down here and y values up here, but what I'm missing is this y value at y equals 0. And so in this case, our range is actually going to be the same as our domain. Okay, so we're both missing 0. Now, let's look at this next characteristic called asymptotes, right? And so our horizontal asymptote, we've colored in sort of this yellowy color, orangey color, and our vertical asymptote is in this green color. And if we were to write an equation for this, it would be at y equals 0. And if we were to write an equation for the green one, we'd have x equals 0. All right, so horizontal asymptote is going to be y equals 0, and the vertical asymptote is x equals 0. And one thing I actually want to point out for us here is that the domain missing 0 is exactly because there's a vertical asymptote at x equals 0, okay? Similarly, the range missing 0 is because of the horizontal asymptote at y equals 0. So whatever our asymptote is, that will tell us what point we're missing, okay? All right, last thing I want us to take a look at here is the idea of end behavior. And so if I look at this graph and I trace it out to the left end, just going this way, this way, this way, this way, the y value is getting really close to 0, okay? Now, if I look on the other side, same thing, I'm tracing the function, tracing it, that y value is getting really close to 0. All right, so when we say left end behavior here, I want to say that the y value gets close to 0. All right, and same thing over here, the y values get close to 0. All right. And that's different from our previous section where we had the up, down and the down, up. These ones just kind of go sideways, but in particular, they get close to a specific y value. All right. Okay, my friends, this is where we're going to stop this video. Come on back for some practice on the graph transformations in part 2.